Good morning, everyone. Am I audible? Students, am I audible? Or my voice is low? Audible, right? Okay. So, we are going to start with the new chapter today, that is conic section. In conic section, we are going to start, okay, with the circles. You're able to see the screen, right? Okay. Okay, let's start with the conic section part. I'll go little fast. The conic section full explanation I'll give when it comes the other parts. But first, try to understand this entire conic section is divided into four parts. The first is circles. The next part is parabola. The third part is ellipse, and the fourth part is hyperbola. Each part is like a separate chapter in itself. Okay. So actual conic section, this actual conic section, I'll start from this three chapters: parabola, ellipse, hyperbola. So what is basically a conic section? Why this three or this four are called as conic section? All these things I'll discuss in detail when I teach the parabola part. Today I'm going to go with the circles, which are already you have studied in your lower classes and you already know. Okay, what is a circle basically? So that is why I'm going to start with the circles, and I'm not starting with the definition of what is a conic section. Okay, I'll keep it that for the parabola part. Okay, let's start with a circle. So how can you define a circle? You can define a circle as locus of all such points which are equidistant from a fixed point. Which are equidistant from a fixed point. And we very well know that this fixed point is called as center, and this fixed distance is called as radius. So this definition itself is going to help us in finding out the equation of the circle. Okay, you guys can take a screenshot of this, or else I'll share the PDF. Don't worry. Okay, I'll share the PDF with you guys. Okay, so let us derive the equation of the circle. So what we are going to do is we are going to derive equation of standard circle. So what do I mean by standard circle? When do we call anything standard? So in this case, the circle is called a standard if the center lies at origin. For different conic sections, it will be different, but whenever you hear the word standard, it is always to do something with origin. Okay, it has always to do something with origin. So what is the standard circle is? The circle whose center lies at the origin. So I am considering a circle whose center is at the origin. I am considering a point P, x comma y, and what I am doing is I am trying to find out this equation of this circle. So these distances are, now we have already defined, what did we define? It is a locus of all such points which are equidistant from a fixed point, that is the center. And that equal distance is nothing but radius. Okay. which means the distance of the point from the center. Okay, that is distance OP is constant. This is what it means. And that constant distance is nothing but R. So how do we find out distance? But obviously by distance formula. Okay, we find out distance by distance formula. So this distance OP will be nothing but under root of x minus 0 the whole square plus y minus 0 the whole square. So I'll get OP is equals to nothing but x minus 0 is x, so x square, y minus 0 is y, so this will become y square. And this OP is nothing but r, so I'll write it as r. So now if I want to remove square root, I will have to take square, so I'll get it as x square plus y square is equals to r square. So this is the required equation of the circle. And this is nothing but equation of a standard circle. So we can call this as equation of the circle in the standard form. Okay, we can call this as equation of the circle in the standard form. So now it is not compulsory that center should always be at the origin. So center can be somewhere else also, right? So I am going to consider like that only. So if I have center at some other point, say h comma k, then by this distance formula we had x minus 0, which will now become x minus h, and we had y minus 0, which will now become y minus k, right? Here we had this x minus 0. But now center is h comma k, so instead of 0, I'll put h and k over there, and again I'll get this resulting equation. Okay, and I'll get the resulting equation as x minus h the whole square plus y minus k the whole square is equals to r square. So this is also called as equation of circle in center radius form, because you have a radius and you have a center. So this is called as equation of circle in center radius form. This green color is equation of the circle in standard form, and this red color one is equation of the circle in center radius form. We can have one more possibility, and that possibility is something like this. That possibility is something like this. Suppose I am knowing the diameter of this, and I know the points of the diameter. Say one point is x1, y1, and the other point is x2, y2. This time I don't know the center, I don't know the radius. What I know is the diameter of the circle. So, just by using the diameter also, we can find out the equation of the circle, which we call it as diameter form. So, how do we find out over here? So, it is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. So this is also equation of the circle. This is also equation of circle, and this is called as equation of circle in diameter form. So this is equation of circle in diameter form. So you just have to remember these three things, nothing else in the entire chapter. Okay, there are three ways in which I can write the equation of the circle, and those three ways are equation of the circle in standard form, equation of the circle in center radius form, and equation of the circle in diameter form. Okay, you guys can take the screenshot of this. Okay, I hope everyone has taken the screenshot of this. Okay, let's do some example to understand how to use this given things. Whatever I've explained you, how to use these concepts. So, okay. So I have to find out equation of the circle whose center is minus 3 comma 1 and which passes through point 5 comma 2. Okay, the question is something like this. I have to find out equation of circle whose center is at minus 3 comma 1 and which also passes through the point 5 comma 2. So now if you just remember, we saw only three forms, which is a standard form where the center lies at the origin, then center radius form, and then diameter form. So to find out the equation of the circle, we should be have at least one of the form. So what I can do is, at least I know center, so I can go for center radius form. Okay. So C point is somewhere here, P point is somewhere here. So but obviously this is going to be my radius. So I can easily get the radius by distance formula. Is 5 minus 3, that will become 5 plus 3 the whole square plus 2 minus 1 the whole square. So that is 8 square, that is 64, and 1 square, that is 1, so root 65. So my r square will be nothing but 65. So if you remember what is center radius from x minus h the whole square plus y minus k the whole square is equals to r square. So the equation can be written as x minus h. So x minus minus will become plus. So x plus 3 the whole square plus y minus 1 the whole square is equals to 65. R square is nothing but 65. So let's just expand. So I'll get x square plus 6x plus 9 plus y square minus 2y plus 1 is equals to 65. So I'll get x square plus y square plus 6x minus 2y. 9 plus 1 is 10, 65 minus 10, so that will be 55. Minus 55 equals to 0. So this is the required equation of the circle. So in the question, he said us to find out equation of the circle which was passing through a point minus 3 comma 1 and the point 5 center was at minus 3 comma 1 and passing through the point 5 comma 2. So if you see, this is the equation of the circle and the standard equation of the circle. If you remember, standard equation of the circle was something like this: x square plus y square is equals to r square. This was the standard form. But now the equation of the circle which we have got is not something like this. It is not only x square plus y square is equals to something. I have a very big equation. So this will be called as general equation of circle. So the form which I've got is not a standard form. So it is understandable since it was not lying at the origin. Since the center was not lying at the origin, that is the reason why I've got the equation of the circle something like this. So I can also represent it something like this. Equation of the circle of the form x square plus y square plus 2gx plus 2fy plus c equals to 0 represents equation of the circle. So whenever you see equation something like this, of this form, x square plus y square plus something plus minus something. It will always be the equation of the circle if and only if. This will represent equation of the circle if and only if the value of g square plus f square minus c is greater than 0. So this general equation x square plus y square plus 2gx plus 2fy plus c equals to 0 will represent equation of the circle if and only if g square plus f square minus c is greater than 0. So suppose we do the reverse thing. I know the equation of the circle and I want to find out its center and radius. So how do I find out? So by simply using this formula, I can get, okay, so my radius will be nothing but equals to square root of this term which we had written over there, g square plus f square minus c. This will give me radius and my center will be equals to minus g comma minus f. Radius will be this and center will be this. Okay, so let's do this reverse so you will understand. So we have solved one numerical right now and we got the equation of the circle. If I compare this with this, so I'll get 2g is equals to 6. I'll get 2f is equals to minus 2. I'll get c is equals to minus 55. If I compare both those equations. So now I can get the value of radius as r is equals to under root of g square. So 2g is 6, so g is 3. So 3 square, that will be 9 plus f square. 2f is minus 2, so f will be minus 1. Minus 1 square will be 1. Minus c. So minus minus will become plus. So this will give me plus 55. So that is root 65 r. So you can see here we had got that only. We had got the value of r as root 65. Then center minus g comma minus f. So center minus g. So g is 3. So minus g will be minus 3. Okay. And minus f. F is minus 1. So minus minus, that will become plus. So I'll get center 3 comma 1. So now if you compare, you can clearly see. See in the given question, the center was minus 3 comma 1. So we have got minus 3 comma 1. And the radius what we had got as root 65. So here also we have got root 65. Okay, so reverse also we have understood. So this is very important. Okay, general equation of the circle. Keeping in mind this particular thing is important. General equation of the circle can be represented something like this, and the radius and the center could be found out something like this. So please take the screenshot of this, everyone. And if you guys are not understanding at any point, please okay, unmute yourself and ask me the questions. Okay. Okay, I hope you have understood. Let's see some other kind of numericals. So we'll understand how to find out. Okay. We have to find out equation of the circle with a is equals to 2 comma minus 3 and b is equals to minus 3 comma 5 as the diameter of the circle. So this time we have been given with the diameter. So if we know the diameter, we'll go for the diameter form. If we know the diameter, we'll go for the diameter form, right? So what is the diameter form? X minus x1. So this becomes your x1 y1. This becomes your x2 y2. So x minus x1. So that is x minus 2 into x minus x2. So that is minus minus will become plus. Plus y minus y1. So minus minus will become plus into y minus y2. So y minus 5 equal to 0. So I'll solve this equation. So x into x, that will be x square plus 3x minus 2x minus 6 plus y square minus 5y plus 3y minus 15 equal to 0. So I'll get the equation of the circle as x square plus y square plus 3 minus 2, so that will be plus x, minus 5 plus 3, so that will be minus 2y, minus 6 minus 15, that will be minus 21 equals to 0. So this is the required equation of the circle. So I had to find out the equation of the circle which is passing through the 2 points, and these 2 points are nothing but end point of the diameter. Okay, I hope it is clear. Let's move on to the next kind of numerical. You guys can take the screenshot of this. I hope everyone is taking the screenshot of this. Let's move on to the next question. So it says that find the equation of circle whose center is at whose center is at 3 comma minus 4 and line and line 3x minus 4y minus 5 equals to 0 cuts circle at A and B. Cuts circle at point A and B where length AB is equals to 6. So drawing the circle will help us understanding actually what is saying in the question. So let's draw a circle. So there is a circle something like this whose center is 3 comma minus 4. There is a line something like this as per the question, which is cutting the circle at 2 points A and B. Length of this segment has been given as 6 units. And what is saying us? In such scenario, I have to find out equation of circle. So for the equation of the circle, what do you require? You require radius and you require center. Center has been already given to us. So this is going to be my radius. If I get the value of the radius, I'll get the equation. But I have to find out because I don't know the coordinates of A, I don't know the coordinates of B. But I know one thing from my 10th standard, that if I draw a perpendicular from the center to the chord, it will always bisect the chord. So this will become 3 and this will also become 3. So if somehow I am able to get the value of this Cm, then by Pythagoras theorem I can find out the value of R. So that is what I am going to do. So how I can find out length Cm? So I had already explained you. This length Cm can be found out by this formula. This distance is perpendicular distance of a point from a line. So ax1 plus by1 plus c upon under root of a square plus b square. So I'll substitute this point in the equation of the line, and this is how I can get Cm. So Cm will be nothing but A. A I'll get from the line, this is my A, this is my B. So 3 into x1. x1 is this point. Okay, 3 plus B. B is minus 4 into y1. y1 is also minus 4 over here. Minus 4 plus C. C over here is minus 5. This is minus 5 upon under root of a square plus b square. So my a is 3 and b is 4. So 3 square plus 4 square. So from here I'll get the length of Cm as 3 into 3, that is 9, minus 4 into minus 4, so that will be plus 16 minus 5 upon 9 plus 16. So 9 plus 16, that is 25, 25 minus 5, that will be 20. So it will be 20 upon square root of 25, that will be 5. So that will give me 4 units. So now I know the length Cm also as 4 units. I know the value of MB also as 3 units. So I can get the value of R by Pythagoras theorem, right? So that is what I'm going to do now. I'll apply Pythagoras theorem. So my radius, which is nothing but BC as per the diagram, my BC square will be nothing but CM square plus BM square. So that is R square is equals to CM, that is 4 square plus BM, that is nothing but 3 square. So I'll get R square is equals to 16 plus 9, which is 25. So I'll get the value of R as 5. So center radius form, I know the center, I know the radius, so I can get the equation of the circle as x minus h, so x minus 3 the whole square plus y minus k, minus minus will become plus, so y plus 4 the whole square is equals to r square. So that is 5 square. So I'll get x square minus 6x plus 9 plus y square plus 2 into 4, so that is 8y plus 16 is equals to 25. Somewhere some mistake, I guess. What mistake I did? Sorry, this CM is 4, right? So 4 square plus 3 square. So that is going to give me this. So I'll get the final equation as x square plus y square minus 6x plus 8y. 16 plus 9, 25. There also I have 25, 25, 25. Cut equal to 0. So this is the required equation of the circle. X square plus y square minus 6x plus 8y is equals to 0. So I hope you have understood how to apply the things, how to find out the equation of the circle. Please take the screenshot of this. I hope everyone is taking the screenshot of this. I'm deleting it. Okay, now let's see next important thing, parametric equation of circle. So what is the parametric equation is whenever you want to reduce the number of variables. Okay, whenever you want to reduce the number of variables. What we do is we define those two unknowns into the terms of other one unknown. So number of unknowns will reduce. Let me give you an example. So this is my circle. This is any point on the circle, say x comma y. This is circle considering it as the origin, center at the origin. So if this is x coordinate, so but obviously this distance will be x, and if this is my y coordinate, so but obviously this vertical distance will be y. Let me denote this angle as theta. Then by applying trigonometry, okay, over here, okay, then from by applying this uh, in this particular triangle trigonometry, I can write sine theta is equals to opposite that is y, and this is my radius OP upon r. So from here I'll get y is equals to r sine theta. Similarly, I can get cos theta is equals to adjacent upon hypotenuse, that is r. So from here I'll get x is equals to r cos theta. So these two what we've got are called as parametric equation of circle. X is equals to r cos theta, y is equals to r sin theta. This is what we call it as parametric equation. So now if you can see there is only one variable r. R is the distance. Distance is constant. So you have only one variable, which is that this theta. This theta is only the one variable. So initially there used to be two variables. One was x and one was y. Now what happened? It got converted into a single variable, which is theta. I have defined x also in terms of theta and y also in terms of theta. So now I have only how many unknowns? I have only one unknown. And what is that unknown? That is theta. Okay. So that is the advantage of a parametric equation. So in parabola, ellipse, hyperbola, everywhere we are going to see this parametric equation. Okay. And the work of this parametric equation is reduce the number of variables. Okay. I hope you have got it. What do you mean by parametric equation of the circle? Okay, please take the screenshot of this, everyone. Please take the screenshot of this. I hope everyone is taking the screenshot. Okay. Next, we are moving to a very important topic called as tangency. So we know that a line which touches the curve, not only circle, line which touches the curve at one and only one point will be called as the tangent. So what is a tangent? Line touching any curve, not only circle, at one point only will be called as tangent. Okay, will be called as tangent. So now here we are going to deal with the problems where we will have to find out the equation of the tangent. So this applies for all circles, parabola, ellipse and hyperbola. So understand it here itself. I will not explain you again and again. So when you want to find out the equation of the tangents, there are three ways in which we can do it. There are three ways in which I can find out an equation of the tangent. One is the method of derivative. One is condition of tangency. And one is by formula. Okay. So when I go with method of derivative and formula, I should know point of contact. If I don't know the point of contact, I cannot find out the equation of the tangent. I can find out the equation of the tangent if and only if I know the point of contact by using derivative or the formula method. But the beauty of this is we know the equation of the line can also be given as y is equals to mx plus c, which is the slope tangent slope intercept form. So if there is any line y is equals to mx plus c, and if that line wants to be tangent to the curve, then it has to satisfy certain condition, and that condition is called as condition of tangency. So this is the more general method. So when we don't know the point of contact, we can go for this. Or so there are three methods to find out the equation of the tangent. Okay, because if I consider a circle, there can be three different types of line. There can be one line which is going something like this. There can be another line which is just touching the circle. And there can be one more line which is not touching the circle at all. There is one line which is touching the circle at 2 points. There is one line which is touching the circle at 1 point. And there is one line which is not touching the circle at all. So there are three possibilities only. So all these three lines can be denoted by this particular thing only. Y is equals to mx plus c. So when can a line be called as a tangent? It is only in this condition. So this is what we find, we call it as condition of tangency. So for each conic section we are going to find out condition of tangency. So this line y is equals to mx plus c will be tangent to the circle if and only if c square is equals to a square m square plus a square. Remembering it in this format is important because it will help you to remember the formula of ellipse and hyperbola also. So from where you will get C? From the equation of line. From where you will get M? From the equation of line. And from where you will get A? From the equation of circle. Okay, this A is nothing but radius. So from where you are going to get A? You are going to get A, okay, from the radius. That is from the equation of the circle. And from where you are going to get the value of C and M? You are going to get the value of C and M from the line. So if any line is satisfying this condition, then it is tangent. If it is not satisfying this condition, then it is not a tangent. As simple as that. Okay. Next. So we have seen condition of tangency. Now let's see formula method. So see in the formula method, be it circle, be it ellipse, be it parabola or be it hyperbola. You have to remember these tricks. I'll not tell you to by heart the formula. Instead, you just remember this trick. Wherever there is x square term, replace it by xx1, replace y square by y1. Okay. Then wherever there is 2g x, replace it with g into x plus x1. We have seen the general equation of the circle, right? X square plus y square plus 2gx plus 2fy plus c. So that 2g term you have to replace it with, okay, xx1, then it was 2fy. So 2fy term, so 2 you have to divide by 2 and this will remain only f. Y should be written as y plus y1. Just remember this much, okay? You just have to replace these terms and you will get the equation of the tangent very easily. So say you have been given the equation of the circle as x square plus y square plus 2gx plus 2fy plus c is equals to 0. This is the equation of circle. Then equation of the tangent will be given as, so what I said, wherever there is x square, you have to replace it with xx1, so I'll write it as xx1. Y square will be written as yy1. 2gx will be written as g into x plus x1. 2fy will be written as f into y plus y1 plus c equals to 0. So this will become the required equation of the tangent. And what is this x1, y1? X1, y1 is point of contact. And this becomes my required equation of tangent. So very easy method. Okay, suppose you have this standard circle, something like this. X square plus y square is equals to, say, r square. So how you will write equation of the tangent? Simple. Wherever there is x square, you have to replace it with xx1. Wherever there is y square, you will replace it with y1 is equals to r square. So this will be the required equation of the tangent. So if the point of contact is known, okay, then this is how you can find out the equation of the tangent. I hope you have understood how to find out the equation of the tangent. So please take the screenshot of this. Please take the screenshot of this. So now we know how we can find out the equation of the tangent. We are going to do the numericals pertaining to equation of the tangent. Okay, I hope everyone has taken the screenshot of this. Okay, I hope everyone has taken this screenshot. So let's do some numericals now. So understand how to find out the equation of the tangent. So find equation of the tangent. So we are doing one numerical where is saying that you have to find out equation of the tangent. You have to find out equation of the tangent to the circle x square plus y square minus 4x minus 6y minus 12 equal to 0 at minus 1 comma minus 1. So x1 y1 is given as minus 1 minus 1. So how do you write equation of the tangent? Now itself we had written x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equals to 0. So you need the values of all this. So you will compare this with the general equation, that is x square plus y square plus 2gx plus 2fy plus c is equals to 0. So when you compare, you will get 2g is equals to, okay, you will get 2g is equals to minus 4, you will get 2f is equals to minus 6, and you will get c is equals to minus 12. So from here you will get g is equals to minus 2, f is equals to minus 3, and c is equals to minus 12. So we'll substitute these values, and point is minus 1 minus 1. So when we substitute these values, we'll get x into x1 is minus 1, plus y into y1, so y1 is also minus 1, plus g is minus 2 into x, plus x1, so that will be x minus 1. F is also negative, so minus 3 into y plus y1 is minus 1, so y minus 1, plus c is also minus, so minus 12 equals to 0. So I'll get minus x minus y. I'll open the bracket, so minus 2x plus 2 minus 3y plus 3 minus 12 equals to 0. So x minus 2x, that will give me minus 3x, minus y minus 3y, that will give me minus 4y, plus 2 plus 3, that is plus 5 minus 12, so that will give me minus 7 equals to 0. All the terms if I take over there, so I'll get 3x plus 4y plus 7 equals to 0. So this is the required equation of the tangent. So in the given question, he told us to find out the equation of the tangent to the given circle at point minus 1 comma minus 1. So we have used the formula and successfully find out the equation of the tangent as 3x plus 4y plus 7 equal to 0. I hope you understood how to find out the equation of the tangent also. So now let's do some complex numericals. This was just preliminary numericals to understand how to apply the concept. So we have just learned how to apply the concept. Okay. Now we are going to do some exam numericals. I hope everyone has taken the screenshot. Yes. Let's go to numerical. See, those were preliminary numericals. Now, what I'm going to take. These questions I will share with your coordinator, ma'am. Okay, and she will share the PDF with you of the questions. So, let's start. So, it says that one of the diameters of the circle x square plus y square minus 2x minus 6y plus 6 equals to 0. If one of the diameters of this given circle is chord to another circle, there is another circle whose center is at 2 comma 1, then the radius of circle is. So options are root 3, root 2, 3 and 2. So there is one circle whose equation is given, and diameter of this circle. So I am drawing this circle. This is my circle C1, and diameter of this circle becomes chord of another circle. So there is one more circle C2, and the diameter of this first circle is becoming the chord of this second circle. Let me denote this point as AB. And the center of this circle is also given to us as 2 comma 1. Okay. Then I have to find out radius of this particular circle C2. I hope you have understood the question. I hope the question is clear to all. So we know this theorem we have used previously also in one of the numerical. Okay, if I draw the perpendicular to a chord from the center of the circle bisects the chord. So this is nothing but going to become the radius. Okay, and this radius I have to find out. So how can I find out the radius of the circle? So one possibility is, suppose if I somehow know the coordinates of point B, then by distance formula I can find out, or from the given equation if I can find out the radius of the circle, then like last numerical, I'll be able to find out the value of this, and then I can find out the equation of the diameter also, and that is how I can find out the value of let me name this particular point as say M. So like last numerical, I can find out the value of C2M. Once I get the value of C2M, I have the value of BM also. Then by applying Pythagoras theorem, okay, my work will be done. So let's do it. I can easily get the value of M also. M is the center of the first circle. M is the center of the first circle. So if I compare it with the equation x square plus y square plus 2gx plus 2fy plus c is equals to 0. Then I'll get 2g is equals to minus 2, 2f is equals to minus 6, and c is equals to 6. So from there I'll get g is equals to minus 1, f is equals to minus 3, c is equals to 6. So I'll get the center. Center we know it is minus g comma minus f. So it will be 1 comma 3. So the center of the first circle is 1 comma 3. We also know the formula to find out the radius. Radius is under root of g square plus f square minus c. So g square, that will be 1 square, that is 1, plus f square, so that is 3 square, so that will be 9, minus c, so that will be minus 6. So 9 plus 1, 10, 10 minus 6, so that is 4. So square root of 4, so that will give me 2. So I have got the radius of first circle, okay, as 2. So this, which is nothing but BM is equals to AM, which is nothing but equals to 2 units. Okay. Similarly, I can find out C2M also. It's very simple because I know the points. So by distance formula, I can find out. I have the coordinates of C2 also. I have the coordinates of M also. So that will be 2 minus 1 the whole square plus 1 minus 3 the whole square. So I'll get the value of C2M as 2 minus 1, so that is 1 square, so that is 1. 1 minus 3, so that is minus 2 square, so that will be 4. So this gives me root 5. So my C2B by Pythagoras theorem will be nothing but, which I can write R as nothing but root 5 the whole square plus BM. BM is how much? 2. 2 square. So that will be 5 plus 4 root 5 the whole square. So that will give me 5. Okay, this will be R square, sorry. So I'll get 9. So value of R will be square root of 9, that is 3. So what is the answer? Option number C is our answer. I hope everyone has understood. This was asked in the year 2004. This is JEE example. Please take the screenshot of this. See guys, if you're not understanding at any point, then please ask me. Done? I hope everyone has taken this screenshot also. Let's do next numerical. So it is given as lines 2x minus 3y is equals to lines 2x minus 3y is equals to 5 and 3x minus 4y is equals to 7 are diameters of circle are diameters and area of circle is 154 units. Then equation of circle is, So I know area of circle, and I know that there are two lines which are diameters of the circle. Then I have to find out equation of the circle. So what are different ways of finding out equation of circle? One is the standard circle, second is by center radius form, and the third is by diameter form. So in the diameter form, we knew the points. Here we are not knowing the points. So I will have to go by center radius form. So for center radius form, I need center as well as I need the radius. So from where I'll get, so area, we know area is equals to pi r square, which is equals to 154. What yes said. So from here I'll get r square is equals to 154 by pi. I can take the value of pi as 22 by 7 for calculation purpose. So 7 into 154 divided by 22. So I'll get r square is equals to, I guess in 22's table we get this 154. So 22 sevens are is 154. 22 ones are 22 sevens are. So that will become 7 into 7, which gives us r is equals to 7. Okay, so we got radius. Now what we need is the center. How we will get the center? So there is this circle and there are these two lines which are diameters, and we know diameters always pass through the center. Diameters will always pass through the center. So if I solve these two equations, I'll get their point of intersection, and their point of intersection is going to be center. Okay, so let's solve those two equations. So from first equation I'll get 2x is equals to 5 plus 3y, which will give me x is equals to 5 plus 3y upon 2. This equation I'll substitute in the second one. So 3 into x, x is nothing but 5 plus 3y by 2 minus 4y is equals to 7. So I'll get multiplying these 3 inside, so I'll get 15 by 2 plus 9 by 2y. Here also I'll take LCM. So 4 into 2, that is 8y by 2 is equals to 7. So everything is by 2. So this 2 will get multiplied over there. So that is 15 plus 9y minus 8y is equals to 14. So that gives me y is equals to 14 minus 15. That gives me y is equals to minus 1. This value I'll substitute in the above, so I'll get the value of x. So from here I'll get x is equals to 5 minus 3 upon 2. So I'll get the value of x is equals to 1. So I've got the center as 1 comma minus 1. So now you have the center. You also have the radius. So by applying center radius form, you will get the equation of the circle. So equation of the circle is, x minus h, so x minus 1 the whole square, plus y minus k, so minus y minus will become plus y plus 1 the whole square is equals to r square, so r square, that is 7 square. So after solving you will get x square minus 2x plus 1 plus y square plus 2y plus 1 is equals to 49. So I'll get x square plus y square minus 2x plus 2y. 49 minus 2, that is 47, is equals to 47. So this is the required equation of the circle. Okay, I hope you understood how we have found out the equation of the circle. Whenever he is saying you to find out the equation of the circle, you just have to remember how many ways are there. So there are 3 ways. standard form, center radius form, and diameter form. So if we want to find out the equation of this circle, what we require is the center as well as the radius. Please take the screenshot. I hope everyone has taken the screenshot. I'm moving on to the next numerical. Okay. So this next circle says that center of the circle passing through the point. So there is a circle. So there is a circle which is passing through the point 0, 1 and it is touching the curve y is equals to x square at 2, 4. Then center of such circle is option A minus 16 by 5, 27 by 10. Option B minus 16 by 7, 53 by 10. Option C minus 16 by 5, 53 by 10. And option D is none. Okay, let's try to solve this. So, if you plot, it will become little bit easier for you. Okay, so there is this circle which is touching this. So one curve. So this is another curve given as x square is equals to y. Okay, and I have to find out the center of this circle. This circle is touching this curve at point, okay, as given in the question is 2, 4. I need to find out this. And at the same time, this circle is also passing through another point as per the question which is given as 0, 1. I need to find out, okay, the center. So center is going to have two unknowns. We know the center we give it as g h comma k, or we also give it as minus g comma minus f. So there are two possibilities. Means there are two unknowns, so you require two equations. So you have to think in that terms. How, from where you're going to get two equations? So two equations, two unknowns. So the very first and the most easiest way to do is this 0, 1 passes through. So we know that equation of the circle can be given as, so is it possible to find out the radius? So this is also going to be radius and this is also going to be radius. So this distance has to be equal, so h minus 2 the whole square plus k minus 4 the whole square should be equals to h minus 0 the whole square plus k minus 1 the whole square. Right? Why? Because this is also radius and this is also radius. So this I have written by distance formula. So on solving, I'll get h square minus 2h plus 4 plus k square minus 8k plus 16 is equals to h minus 0, that is will be h square plus k square minus 2k plus 1. So h square k square h square k square gets cut. So here I'm going to have minus 2h minus 8k 16 plus 4, that is going to be 20. And here I have minus 2k plus 1. Okay. So from here I'm going to get one equation. I'll take all these terms over there. So I'll get 2h minus 2k plus 8k. So that will be plus 6k plus 1 minus 20, or 1 I'll take over here. So I'll get 19. This is one equation. Okay. 2h plus 6. Oh, I have made mistake, right? H minus 2 the whole square. So this will be 4h. 4h. So this will be 4h. So 4h plus 6k is equals to 19. This is one equation. You require at least two equations. Why? Because there are two unknowns. You need to find out the center. So center is h comma k, two unknowns. Math says two equation. So from where you're going to get the other equation? Uh, how can I get the other equation? So here I will have to bring little bit of derivative, otherwise I am not going to get the other equation. Okay, I have one thing is, here I can construct a tangent. So this particular is going to be the tangent. So I can find out the equation of the tangent, and from there I can find out the slope. I don't know the equation of the circle, but I know the equation of the other curve, which is x square is equals to y. So by derivative method, your dy by dx is nothing but equals to the slope. So I have been given y is equals to x square. So if I take derivative of this, I will get dy by dx is equals to 2x. Now the point of contact is given. Okay, and the point of contact is nothing but 2 comma 4. So from here I'll get dy by dx, which is nothing but m, which is nothing but 2 into 2, which is 4, because my x coordinate is 2. And if you see this, we know radius is perpendicular to the tangent. We know that radius is perpendicular to the tangent. So if I denote, the slope of the tangent as m1 and slope of this is m2, we know radius is always perpendicular to the tangent, hence I can say that m1 into m2 is equals to minus 1. This is the condition of perpendicular lines. So I can say m1 into m2 is equals to minus 1. Therefore m2 is nothing but equals to minus 1 upon m1. Therefore I'll get m2 is equals to minus 1 upon a value of m1, I've got it as 4. So that is minus 1 by 4. Okay. So we know the slope is also given as, in the lower standards which we have seen, y2 minus y1 upon x2 minus x1. So I can write m2 as y2 means k minus y coordinate of this, h minus x coordinate of this point 2 comma 4, right? Okay, this. So from here m2 I've got it as minus 1 by 4. So minus 1 by 4 is equals to k minus 4 upon h minus 2. So this goes over here, this comes over here. So from here I'll get minus h plus 2 is equals to 4 into k. So that will be 4k minus 16. So this term I'll take over here, this I'll take over here. So I'll get h plus 4k is equals to plus 2 minus 16. So that will be plus 18. So this is my second equation. So this is, I've got second equation. So the first equation is 4h plus 6k is equals to 19. And the second equation I've got it as h plus 4k is equals to 18. So when I solve these two equations, okay, solving equation 1 and 2 simultaneously. So I'll get the value of h as minus 16 by 5, and I'll get the value of k as 53 by 10. So I've got the center as minus 16 by 5 comma 53 by 10. So let's see which option is matching. So in the question, minus 16 by 5, A and C, 53 by 10. So option C is, it is matching with option C. So option C is my answer, minus 16 by 5 comma 53 by 10. Okay. So I hope you have understood. You can take the screenshot of this. I hope you have understood. The question was given the center of the circle which is passing through 0, 1 and touching the curve y is equals to x square, or to 2, 4. I have to find out the center of such circle. So I've got this. Okay. In the next class, we'll do some more numericals, and then we'll be able to complete circles, and then we'll start with the next part, that is parabola. Okay. So time is also done, and next 2 minutes I'll not be able to take any numerical. Okay, so have a nice day ahead.